Hello, class. In today's video, we're going to talk about two different questions that we can use the fundamental theorem of calculus to answer. So here we're going to be talking about the integral from -2 to 2 of x minus 1 times x plus 2. And I've given you a graph of x minus 1 times x plus 2. You can see that it's accurate in that it at least is 0 at -2 and 0 at 1. And I've shaded the area that lives between the graph and the x-axis, so you can see that it's made up of two parts. Okay, so we know that if I calculate this integral, what I'm going to get, so this integral, from -2 to 2 of x minus 1 times x plus 2 dx. In terms of the picture, what is this going to be? It's going to be the red area, or the pink area if you like, minus the blue area. And that's because definite integrals count area below the axis as negative and area above the axis as positive. So I'm going to answer first this question that I called A up here. What is this integral? That is, what is the red area minus the blue area? Well, we can do this by using the fundamental theorem of calculus and a little bit of algebra. So I'm going to rewrite this. This is x squared plus x minus 2 dx. So the antiderivative here, using this notation from the last video, is x cubed over 3 plus x squared over 2 minus 2x, all evaluated as x goes from -2 to +2. And so if I continue this onto the next page, that's going to work out to be 8 over 3 plus 4 over 2 minus 4 minus, and then don't forget to put all of these parentheses, minus 8/3 plus 4/2, and then minus a minus 4, so that's +4. Okay, so let's try, that's 2 minus 4, so this is 8/3, minus 2, minus, and then 8/3 plus 6, which is 8/3 minus 2. Oh, sorry, I skipped that minus. Minus 8/3, this is minus 2, plus 8/3, minus 6. So that is 16/3, and then minus 8, which is minus 8/3. Okay. Now, you might ask yourself whether it's surprising that this answer is negative. But if you look at the graph, it probably shouldn't be surprising that the red area minus the blue area is negative, because the blue area is definitely bigger than the red area. Okay. So that's how we would answer that question. What's the definite integral, which will give us the area of the red region minus the area of the blue region. It'll be minus 8/3. Okay. But that's not how we'd answer the second question. So the second question here, I'll reframe it down here. What is the total area, the total shaded area, in the graph? Okay, and so this phrase, total shaded area, indicates that if I frame this in terms of the red area and the blue area, it should be the red area not minus the blue area, which is what we calculated before, but the red area plus the blue area. Okay, so this is again getting at some level of subtlety in what we're talking about here with integration. Namely, the definite integral counts area below the axis as negative and area above the axis as positive. And it does that whether we want it to or not. That's just how the definite integral works. In particular, that's the thing we can calculate. But in reality, area is never negative. Area is always positive. And so if someone asks you a question, not about the definite integral itself, but if they ask you a question about area, then we have to do more work to answer it. So I want to figure out, actually, what is the red area, what is the blue area, and so what is the total shaded area? Now, I know you might be thinking, okay, well, this was negative 8/3, maybe it's just plus 8/3. But in fact, it's definitely not plus 8/3, because some of the red area and blue area canceled in getting us this minus 8/3. So I'm going to have to do more work to get to the point where I can actually answer this question. Okay, so I need to figure out what's the red area, what's the blue area, and then I'm going to add them together, and that will give me the answer to this question. Again, just to reiterate, this minus 8/3, it is the answer to a question. Namely, it is the answer to the question, what is the integral from minus 2 to 2 of x minus 1 times x plus 2 dx? This is the answer to this question. But this is a different question. This question is saying not about the integral, which is minus 8/3, but if we actually counted it the way we would have counted it before we even thought about the integral as both being positive, what would we get? Okay, so to do this, I'm going to reproduce this picture over here, and I'm going to drop the graph off of the screen. But I'm going to draw something that approximates the graph that we just saw well enough that we can label things in it. So it was some parabola that looked like this, where here was 2, here was minus 2. And so this is the area that we called the red area. And this was the area that we called the blue area. And so what I want to find is I want to figure out what each of those areas actually is. Okay. So to do that, I want to make sure I know where this point is first. Namely, this point here, this is the x-intercept of the function we're graphing. So I can solve for it by setting the function we're graphing, which is x minus 1 times x plus 2 equal to 0, which will give me x equals 1 or x equals minus 2. Okay, so that's the one at minus 2. So this is at x equals 1. So in order to figure out the red area and the blue area, I'm going to have to answer those two questions separately. And so I'm going to figure out what the red area is, I'm going to figure out what the blue area is, and then I'm going to add them together, and that will be my answer to this question that I called question B. Okay, let's start with the red area. The red area is the area between the x-axis and the graph, and it's above the axis, which means that I can count this area just using a single definite integral. Namely, the red area is going to be exactly the integral from 1 to 2 of x minus 1 times x plus 2. Okay. How do I know that? Because the definite integral itself counts this area as positive. So I don't have to do anything special to convince the definite integral to answer the question I actually want to know the answer to. The definite integral already answers the question I want to know the answer to. So I have to recalculate this. I'm going to save a bit of my work from before because this function is the same as the function that we calculated this over here for, which means the antiderivative of this function is still the same. Note, it's not the same integral, because here the integral is going from 1 to 2, whereas here the integral went from minus 2 to 2. But the antiderivative, that doesn't have anything to do with the limits, so that I'm going to copy. So this is x cubed over 3 plus x squared over 2 minus 2x, evaluated as x goes from 1 to 2. Okay. So what is that? Well, this is 8/3 plus 4/2 minus 4 minus 1/3 plus 1/2 minus 2. Okay, so we'll do a little bit of fractiony maths. This is 8/3 minus 2 minus 1/3 minus 1/2 plus 2. Okay, so the plus 2 and the minus 2 cancel out. 8/3 minus 1/3, that's 7/3. So this is 7/3 minus 1/2. I put these things over the common denominator of 6. So this becomes 14 over 6 minus this becomes 3 over 6. And so this is 11/6. Oops, sorry. And so what's our conclusion? The red area is 11/6. Okay, so that's half our answer. What's the other thing we have to figure out? Well, we also have to figure out the blue area. So the blue area and here's the rub. We want the blue area to be counted as positive, but the definite integral wants it to be counted as negative. Okay. So the answer we want is related to the integral from minus 2 to 1 of x minus 1 times x plus 2. But it's not this, because this number is actually the negative of the answer. But how do you get the actual answer? Well, we take the absolute value of this. So the blue area is actually the absolute value of this definite integral. And so we can go ahead and just continue on from here. So this is the absolute value of the integral from minus 2 to 1 of x squared plus x minus 2. Okay, and again, I can use the thing from before, so I can reuse the fact that I already know the antiderivative of x minus 1 times x plus 2. So over 3 plus x squared over 2 from minus 2 to x equals plus 1. Okay, notice this bar is not an absolute value bar. Only the outside ones are absolute value bars. Okay. So this is the absolute value of, and so 1/3 plus 1/2 minus 2 minus 8 over 3 plus 4 over 2 plus 4. Okay. Please note you cannot distribute absolute values over things, so I have to calculate and simplify this whole number before I do anything with these absolute values on the outside. Okay, so this is 1/3 plus 1/2, that's 5/6 minus 2 minus 8/3, so that will be plus 8/3, and then minus 2 minus 4. Sorry, it should be an absolute value bar. Okay, so here's a 5/6 plus an 8/3. 8/3 would be 16/6, so 5 plus 16 will be 21. And so this will be 21 over 6 minus 8. Okay, so this is going to be the absolute value of 21 minus 48/6, which is going to be the absolute value of minus 27 over 6, which is going to be 27 over 6. And actually, if you look, that simplifies. That's actually 9/2. Now, I want to note, from the way this worked out, we see good evidence that we did things correctly, because we knew from the graph that the definite integral was going to count this area as negative. Namely, we knew that when I took the integral from -2 to 1 of this thing, that is, when I took the absolute value of this, the thing I was taking the absolute value of was supposed to be negative. Okay. And I saw that at the very last step here, that this thing was really negative, so I really did take the absolute value. So that at least gives me some evidence that things went right. Now, these two pages together allow me to answer the question, which was, what is the total shaded area? Namely, it's the red area, which was this, plus the blue area, which was this. So it is 11 over 6 plus 9/2, which, if I go ahead and rewrite, that is going to be 11 over 6 plus, and then so that will be 27 over 6. And so that will mean this is 38 over 6, which is to say that it is 19/3. Okay, that is the total area that is represented by the shaded area in this graph that we started with. You can check, by the way, that when we did the integral originally, and we got that it was minus 8/3, that was the very first thing we did here, that really is the thing that we're now saying is the red area minus the blue area. Namely, if you do take 11/6 and you subtract from it 27/6, then you would get 11 minus 27/6, which would be minus 16/6, which would be minus 8/3, which is exactly this thing here. So these two questions that we talked about at the beginning, the question, what is the definite integral, and the question, what is the shaded area, they're both answerable by knowing both what the blue area is and what the red area is. But the way in which they're combined is a little different. So when you're answering questions on the homework and in your life in the future, make sure you're careful about which number it is you actually want. Okay. I'll do another video with a few more examples of this, but until next time, be well.